My name is Pierre, and I will be the master of ceremony of the day. We appreciate you taking time off your weekend to join us today. It is our privilege and honor to have you all here. We hope you will find the sessions to be fruitful and very engaging. Okay, now, before we get even deeper into the sessions, I would like to explain some technicalities and rules of which shall be obeyed by every attendees during the event. The session itself will be separated into 3 grand sessions, of which in the first one, we will hear a presentation by Mr. Lutfi about cloud computing applications in optimizing geological data processing. As in the second one, we will hear a presentation by Mr. Sashi about the effect of utilizing cloud computing for geological data processing in the Industry 4.0 era. After the presentations, we will then open the floor to those who would like to ask questions to both of our speakers. And as I have mentioned before, there are rules that needed to be obeyed by each and every attendees. The first one is that every attendee shall use name of institution dash name of participant as their name format. For example, if I were a participant, I will use ITB dash Pierre as my display name. Attendees are not allowed to open their camera and microphone during the event without any permission from the committee. As for this matter, the only chance for attendees to be permitted to open their camera and microphone will only be during the discussion and closing session. The third one will be spamming is not allowed in the comment section. And the fourth one, or the last one, is that any attendees who wish to ask any questions shall send it through the comment section after I open the discussion session. Afterwards, the committee will select the best questions of which will be discussed during the discussion session. And also, do not forget to address or to write to whom you are writing the question. Any attendees who disobey the rules will be warned by the committee and will be kicked out of the meeting room if they disobeyed any of the rules after. We would also like to show our gratitude to Esri Indonesia and Bulletin Geologi for the support, and also Ikatan Alumni Teknik Geologi ITB and Suma Corp as our sponsors. Not forget to mention, we would also like to thank 8EH Radio ITB, Anak Teknik, Geologi Net, Ruang Mahasiswa, Berita Lomba, Share Event, Anak Teknik Indo, Geologipedia, Soal Event, lombaonline.com, Info Lomba, Campus Update, and Ruang Mahasiswa as our media partners. Okay, so without any further ado, we will now proceed into the first session. Mr. Lutfi Nugrahadin is a senior geologist specializing in geoscience technical sales. Mr. Lutfi is highly capable in managing business strategy and development, sales pipeline, competitive analysis, and product marketing across different organizations and teams. As for his works, Mr. Lutfi managed to achieve 17.4% YOY revenue growth, overachieved by $1 million in 2019, and also received Schlumberger SIS Award of Excellence for Business Development and Client Engagement in 2018. Mr. Lutfi is experienced in leading projects and even contributed to the first worldwide sales of Explore plant in Indonesia last year. Mr. Lutfi is currently responsible for Schlumberger Geoscience business line for Indonesia operation. Mr. Lutfi received his Bachelor of Technology in Geological Engineering from Bandung Institute of Technology, Indonesia. And now I would like to invite and welcome Mr. Lutfi to join us on the stage. Good morning, sir. How are you today?
Hi, good. Thank you.
Real glad to hear. Okay, so without any further ado, you can now start your presentation, and the floor is all yours, sir.
Okay, thank you. So let me share my screen. How do I share my screen anyway? Is this? Wait, give me a sec. Boom. Wait a sec. Okay, this one. Okay. Let me know, sudah kelihatan screen saya?
Sudah, Pak.
Yes, sir.
Thank you. First of all, saya delivernya campur-campur aja lah ya, bahasa Indonesia, bahasa Inggris. Jadi supaya teman juga nggak hesitate untuk bertanya sebanyak-banyaknya nanti. First of all, thank you untuk kesempatannya. I'm very humble for this opportunity. Saya selalu suka untuk kasih sharing session seperti ini ke teman-teman mahasiswa, especially karena I was in your position and I understand how valuable this kind of session untuk kalian, dan semoga juga sesi ini bisa membawa banyak manfaat lah. Perkenalkan, nama saya Lutfi Nugrahadin. Saya as a technical leader, saya Shashi, if I may, I'll deliver the presentation mostly in Bahasa, but my slides will be mostly in English, so you will get very much.
Yeah, no problem, no problem.
Okay, thank you. Oke, jadi nama saya Lutfi Nugrahadin. Saya as a technical leader-nya di Schlumberger, saya geologist, tapi seperti yang tadi disampaikan, saya lebih ke as a role saya Geoscience Technical Sales, jadi saya responsible untuk Geoscience Sales pipeline-nya DNI Schlumberger untuk di Indonesia. DNI itu, jadi kalau teman-teman pernah dengar, sebelumnya saya harus kasih konteks ini supaya nantinya presentasi saya bisa make sense lah. Jadi DNI itu Digital Integration. Saya join di company itu tahun 2012. Saya lulusan Teknik Geologi ITB angkatan 2008. Saya join right after I graduated di 2012 waktu as a support engineer. Lalu selama 8 tahun saya di company, hampir 8 tahun, belum 8 tahun. Selama 8 tahun saya di company itu sudah lebih dari mungkin 2-3 kali reorganisasi besar-besaran dari tingkat CEO sampai ke tingkat karyawannya lah, kurang lebih. Jadi itu juga nanti kita akan ngobrol lebih jauh soal itu. Cuma DNI sendiri, Digital Integration Division ini adalah divisi di Schlumberger yang core bisnisnya ada luas sekali karena reorganisasi terakhir itu. Jadi dari seismic processing. Sekarang kan kalau seismic acquisition, Schlumberger itu kita udah nggak akuisisi sendiri, kita partner dengan El Nusa. Ya, kita punya MOU dan lain-lain lah dengan El Nusa. Jadi sekarang kalau untuk scope-nya sendiri, jadi dari seismic processing sampai ke geoscience, drilling, anything reservoir engineering, production, data management, tapi semuanya yang berhubungan dengan kayak consulting services, applications, cloud, dan lain-lain. Jadi itu kurang lebih bisnisnya. Dan hari ini saya akan mempresentasikan penjelasan tentang saya sebutnya digitalization lah. Saya sebutnya digitalization. Saya akan presentasikan dari backgroundnya sedikit, apa yang mendrive si digitalization ini, journey Schlumberger digitalization, sampai ke beberapa contoh. Kayaknya kalau saya tampilkan semua contoh aplikasi cloud di Schlumberger yang sekarang ada, kayaknya we will need more than a day kayaknya ya. Apalagi kalau saya mau kupas jauh sekali. Cuma saya ambil beberapa contoh yang saya pikir relevan dengan geoscientist atau geologis. Oke. Jadi bisa teman-teman lihat di slide ini. This is 1980. Can you imagine? Ini 1980. CEO Schlumberger saat itu Jean Riboud, dia bilang artificial intelligence itu bisa change the magnitude of the business. 1980 saya belum lahir gitu, dan pasti teman-teman juga belum lahir. Maksudnya we saw this thing way back, bahkan sebelum industri 4.0 itu ada gitu ya. Jadi he realized that artificial intelligence will be a thing, especially di oil and gas industry, especially di oil exploration, yang dapat mengekspedite semua proses dari perspektif operator, oil company, juga dari perspektif service company. Oke, jadi setelah kita tahu ternyata memang it is no brainer lah kalau digitalization is here, everything is connected now. Jadi it's only matter of question kita in or out gitu aja ya. Jadi di slide ini saya mau tunjukin numbers dulu. Kenapa numbers? Supaya teman-teman bisa tahu apa sih yang mendrive company ini. Kita selama saya di Schlumberger, kayaknya saya going through crisis tuh udah all gas crisis ya. Mungkin sudah 2-3 kali, sampai puncaknya kemarin, saya lupa WTI minus $37. I think it was in April. itu puncaknya lah. Jadi dan I lost my colleagues also along the way gitu. Jadi itu menunjukkan bahwa memang the big players, all the oil companies, all the services companies, they're very reactive to the business situation gitu. Dan they're constantly looking for improvement di semua sektor. Dan memang highly driven by profitability. Jadi mereka mau cut cost sebanyak-banyaknya. Cost itu bisa dalam bentuk apapun, dalam bentuk waktu, dalam bentuk manusianya, dalam bentuk efisiensinya mereka bekerja, dan di semua sektor. Di sebelah kiri teman-teman bisa lihat ada dari exploration, well construction, development and planning, production operation. Ini adalah potential range of impact on global expenditure di conventional EP ini baseline 2018. Dan di sebelah kanan, di lingkaran-lingkaran itu kalian bisa lihat, itu adalah expected result dan actual result sebenarnya. Yang lingkaran warna biru itu expected resultnya. Jadi bisa lihat, the 3 out of 20 dry holes will not be drilled, 30% saving di capital, 20% saved by drilling sumurnya lebih cepat gitu ya, 10% dari OPEX. Lalu ada beberapa actual resultnya, yang di sebelah kanan atas yang lingkaran warna kuning itu BP kalau nggak salah di Gulf of Mexico. Ada months of seismic processing juga itu karena di cloud computing ini kita banyak meliberate high performance computing atau high performance engine gitu ya. Jadinya banyak proses-proses yang tadinya kita butuh massive engineering, massive computer gitu, sekarang mungkin kita bisa manfaatin cloud. Lalu ada juga peningkatan produksi 30,000 barrel per day. Jadi gitu. Jadi ini menunjukkan bahwa memang perusahaan-perusahaan ini they're driven by profitability. Dia akan memikirkan bagaimana cara dia bisa cutting cost sebanyak-banyaknya dan bagaimana cara mereka dapat mengachieve sesuatu yang tadinya mereka bisa achieve, contohnya dengan 20 orang dalam waktu 1 tahun, mungkin they're taking of days. Jadi salah satu early adopters dari cloudnya Schlumberger itu Woodside. Woodside itu national oil companies-nya Australia. Ya. In one of the interviews, dan I'm pretty sure it was there up in YouTube, kalau kalian bisa mau ngecek, in one of the interviews, they bilang, when we adopt this cloud technology, we're not looking at 5% or 10% improvement. That's a failure, kata mereka. That's a failure. We're looking at 50%, 60%, 70% of improvement. Jadi memang yang mendrive si company untuk think of digitalization atau digital transformation adalah mereka ingin lebih efficient in all sectors. Jadi that's why as a company mereka bisa tetap profitable. Gitu. Jadi that's what drive them. Especially sekarang kita ada di kondisi pandemi, kita butuh flexibility, kita butuh mobility untuk bekerja gitu ya. Kalau teman-teman tahu, kalau teman-teman bayangin ya, di oil companies kan mereka kerja di belakang workstation. Mungkin teman-teman juga punya lab, ada subsurface laboratory di kampusnya. Bayangin kalau tiba-tiba mobility kita terblok gitu ya, kita nggak bisa kerja dan kita cuma punya or cell phone or tablet di rumah, gimana cara bisa kita kerja? And that's where cloud environment really makes sense, really fill in that pain gitu. Okay.
Excuse me, Mr. Lutfi?
Yes.
I am very sorry to interrupt your presentation, but a part of the slideshow is covered by a gray box, specifically on the right part.
Okay, sorry. All right, thank you. Right. Is it good now?
It's still covered by, okay, now it's good.
Okay.
Thank you.
No worries. Okay, thank you. Terus sekarang kita lihat another numbers. Kalau sekarang dari sisi market dynamics yang sebenarnya revolve around people and technology, pretty much ya. Jadi ini juga saya mau kasih lihat kenapa, karena supaya teman-teman tahu, supaya kita bisa lebih open minded lah. Di grafik yang paling kiri itu ada gambaran petrotechnical professionals yang kita sebenarnya actually outlook itu defisit. 2021 onwards gitu. Mungkin it can be caused by a lot of things, cuma mungkin demand-nya atau interest-nya ke sini karena melihat industri kita yang seperti ini, dinamisasinya gitu ya. Jadi mungkin interest-nya turun, atau kalau dilihat yang di tengah, makin banyak pekerjaan yang sebenarnya membutuhkan less human touch lah. Jadi ada 80.000 sensors as we speak di modern offshore platform as a teknologinya. Lalu di paling kanan bisa dilihat big players like Shell, Exxon, Total, Petronas, yang lain-lain, mereka sudah punya tim data scientist dan data analyst sendiri. Menunjukkan bahwa mereka sudah memikirkan digital transformation itu. They're thinking about it and they're doing it now. Right? Jadi memang mau kita suka atau tidak, semuanya bergerak ke arah situ. Di Indonesia kita cukup jalannya cukup lambat karena apa? Karena satu hal, kita punya data residency, rules atau ada regulasinya ya. Jadi artinya data yang di Indonesia tidak boleh meninggalkan Indonesia. Itu ada regulasi lebih detailnya, saya nggak akan masuk lebih detail dari itu. Cuma artinya apa? Implikasinya adalah kita nggak bisa outsource microservices atau kita kirim data-data kita ke cloud center di US gitu misalnya. Kita nggak boleh kayak gitu karena that will breach the regulation. Karena datanya harus stay di sini. That's why Schlumberger sendiri, nanti saya akan ceritakan lebih jauh, kita partner dengan Google yang Google Cloud Provider itu sudah ada di Indonesia sejak bulan Juli kemarin, gitu. Dan sudah go live sekarang. Dan disuruh baru kita bisa push digital transformation ke oil and gas operators dan lain-lain, seperti itu ya. Jadi memang ini juga slide-nya saya mau menunjukkan bahwa memang semuanya akan bergerak ke arah situ. Bisa dilihat dari banyaknya data scientist, data analyst yang di-hire oleh company-company ini. Oke, sekarang talking about the journey. Despite of our CEO spoke out about it back in 1980s, tapi kita mulai itu dari 2012. 2012 itu saat saya baru join. 2012 kita mulai bicara tentang digital corporate strategy, digital exploratory projects, kita lihat some visible options yang kita bisa ambil. Lalu di 2014 kita invest a lot kita bikin software technology innovation center, kita hire banyak data engineers, data scientists, kita bikin Schlumberger Limited Industrial Internet Center juga. Lalu kita invest juga kita bikin engineering program. Jadi dan 2016 kita baru come up dengan Delphi Cognitive Environment. Di 2018 kita accelerate semuanya dan kita through partnerships. Jadi mungkin along the process mungkin lebih dari sekitar 400 perusahaan kali ya, 400 companies yang kita partner. Tujuannya apa? Tujuannya buat kita cari company yang punya muscle untuk partner dengan kita dan punya visi yang sama dengan kita lah gitu. Jadi kita partner up dengan mereka untuk mengaccelerate aim kita, untuk mengaccelerate objektif kita gitu. Dan we come up with namanya, kalau di Schlumberger nama produknya Delphi Environment, itu cloud kita. Jadi si Delphi ini ada cloud environment yang di dalamnya banyak sekali kayaknya kalau saya mau jelasin Delphi mungkin harus seharian gitu ya. Cuma in the picture yang paling atas itu application-nya. Jadi kalau teman-teman ada sebagian di sini yang pernah lihat pernah kerja di workstation, atau ada software namanya Petrel, Techlog, biasanya kita punya donation license ke kampus-kampus. I'm pretty sure ada kalau misalnya teman-teman mau tanya-tanya. Techlog Petrel kah atau Petromod gitu ya. Semua aplikasi itu akan ada di dalam Delphi. Yang di bawahnya Tipco, itu partner kita untuk data visualization dan analytics. Nanti salah satunya akan ada di presentasi saya kalau saya nggak salah. Lalu assist automated machine learning, kita kerja sama dengan Google Cloud, Dataiku, Microsoft, dan terakhir adalah platform. Jadi yang paling bawah namanya OSDU. OSDU itu Open Subsurface Data Universe. Teman-teman bayangin, ada banyak sekali software dan aplikasi oil and gas di luar sana gitu ya, macam-macam, dan provider macam nggak hanya Schlumberger aja, ada Halliburton, ada Baker, ada Emerson, Paradigm, banyak sekali gitu ya. Dan saat kita bicara tentang cloud, saat kita bicara tentang digital transformation, we have to talk about the openness. That's a must. Karena kita harus breaking the silos, kita harus kerja bareng-bareng, kita harus jadi OSDU ini lahir dari salah satu Schlumberger, inisiatornya waktu itu kita donating code kita donating data ecosystem sebenarnya di Schlumberger waktu itu namanya. Tapi kita agree with multiple companies. Kalau teman-teman iseng ke websitenya OSDU, OpenSubsurface.universe, you can find more than 100 companies comply with the OSDU. What it means adalah company-company yang sudah tergabung ke dalam OSDU, when we talk about data format, then we speak in the same language gitu. Saat kita bicara data well, then we have same language untuk format data sumur gitu. We have same language untuk format data seismik misalnya. Jadi each of these companies kita sadar bahwa when we have to go digital, kita harus open satu sama lain. Tidak hanya di within Schlumberger sendiri, tapi juga dengan perusahaan-perusahaan lain. Can you imagine that? Karena it's very itu intensi yang sangat bagus lah menurut saya gitu, dan itu progres yang sangat bagus. Artinya ke depannya cloud environment ini dari perusahaan yang beda-beda ini, kalau mereka sama-sama comply di OSDU, let's put it this way, mereka akan lebih mudah untuk terintegrasi satu sama lain lah, kurang lebih kayak gitu. Oke, jadi openness is a must. Kalau kita bicara tentang digital transformation, kalau kita bicara tentang cloud, kita bicara tentang digitalization dan semuanya, openness is a must. Oke, it's very important. Dan again, saya mau reiterate, kalau di Schlumberger sendiri, kita kerja sama-sama Google, partner kita, dan Google Cloud Provider itu udah ada di Indonesia sekarang. Oke, now, sekarang saya mau masuk ke praktis di Geoscience ya, sebentar. Seperti yang saya sampaikan, mungkin agak terlalu banyak kayaknya kalau saya bring semua examples-nya, karena benar-benar range-nya benar-benar dari exploration sampai ke production sampai ke service operation. Jadi saya coba bring 4 di sini. Ada 4 hal yang akan saya coba terangkan ke teman-teman. Yang pertama itu yang atas kiri itu machine learning untuk petrophysical modeling. Yang sebelah kanannya rapid screening. Yang bawah ada accelerated exploration planning, eksplorasi stage-nya, perjalanan kita menuju ke situ sampai ke liberation engine-nya. Lalu di kanan bawah ada machine learning untuk seismic interpretation. Oke, saya harap ini akan cukup relevan dengan teman-teman di sini ya. Yang pertama kita ke yang petrophysical modeling dulu. Oke, sebelum saya jelasin slide ini, jadi saya mau jelasin sedikit. Saya yakin ada beberapa yang familiar, ada beberapa yang enggak lah pasti. Jadi gini. Jadi di suatu proses pemodelan reservoir itu yang dilakukan di Petrel gitu contohnya, itu kita ada salah satu tahap kita memodelkan petrophysical parameter. Apa sih petrophysical parameter? Contohnya kayak porosity, permeability gitu ya. Terus kita juga pemodelan facies. Jadi gini, jadi pemodelan bawah permukaan lah. Jadi kan saya coba jelasin ini semudah mungkin. Jadi kalau misalnya teman-teman lihat kita bisa drill di satu titik, itu kan pasti kita udah tahu di bawah itu ada apa gitu gampangnya. Jadi sebenarnya itu in the background kita buat modelnya. Kita buat modelnya dari data seismik, dari data sumur, kita interpretasi, kita buat structural modelnya, lalu biasanya kita sebarkan nanti data porositasnya seperti apa. Data proses asal dari mana? Data proses kan asal dari sumur, ya kan? Jadi masing-masing sumur punya logging data porositas, terus jadi masing-masing sumur punya tuh sumur A ini data porosity-nya, sumur B ini data porosity-nya, sumur C ini data porosity-nya gitu. Kita di lapangan kita punya kita punya 10 sumur gitu ya. Kita punya 10 sumur, terus lalu dimodelkan tuh porosity-nya di model kita. Pemodelannya itu namanya geostatistik, ada kuliahnya kok. Pemodelan namanya basisnya geostatistik. Jadi kita mencoba mencari hubungan statistik di spasial, di space, di model kita gitu, dari satu titik ke satu titik lain. Tapi it's great, dan we've been using it all this time gitu ya, it works gitu. Tapi sayangnya ada beberapa yang bisa risknya lah ya. Jadi kita banyak menggunakan asumsi, kita harus bikin datanya stasioner, kita harus remove trendnya. Jadi we treat kita doing a lot of adjustment di data kita, dan itu sangat time consuming gitu. Doing your misalnya kamu punya model, teman-teman punya modelnya ada say 10 zone gitu ya. For each of the zone you have to do all those things gitu. Untuk dapat parameter, karena nantinya persebaran data porositas kalian yang nantinya akan kalian pakai untuk volumetric, yang nantinya volumetriknya akan dikasih ke reservoir engineer, lalu reservoir engineer disimulasikan, nanti dikasih ke orang drilling. Jadi semuanya tuh kayak tersambung satu sama lain. Jadi it has to be perfect lah from the beginning gitu. Sayangnya dalam proses itu banyak sekali uncertainty-nya dan sangat time consuming. Dan we bring machine learning untuk property modeling atau total physical modeling. It's very simple dan sangat data driven, dan itu sangat cepat. Mungkin ini reduce from weeks or days to hours. Jadi yang biasanya mungkin kalau kita punya model yang sangat kompleks, mungkin kita bisa, dari pengalaman saya mungkin bisa lebih dari berminggu-minggu kita spend untuk cari parameterisasi yang paling baik gitu ya. Tapi dengan machine learning, it's very simple, dan bahkan mungkin ini agak ekstrim sih. Cuma kalau kalian nggak punya geostatistical experience atau expertise, you still can use it. Gitu. What is scary about it itu seperti itu. Jadi dan it's very data driven. Kalau biasanya jadi biasanya kalau kita punya constraint dalam hal jumlah sumur misalnya di model kita biasanya pakai secondary parameter misalnya untuk membantu kita tahu. Kan kalau misalnya teman-teman bayangin kalau saya punya lapangan 50 km kali 50 km, saya punya 2 sumur atau saya punya 3 sumur lah taruh. Kan di antara titik yang tidak ada sumur saya harus tahu nilai porositinya berapa. Sebenarnya guide nilai porosity saya asalnya ada di sumur itu. Jadi di antara titik-titik itu kalau saya nggak bisa mendapatkan hasil geostatistik yang baik, saya biasanya akan pakai secondary parameter atau driver. Bisa data seismic, bisa anything gitu ya, yang saya pikir akan cocok dengan model kita, tergantung dengan korelasinya dan segala macam lah gitu. Jadi intinya, tapi kalau di machine learning kita bisa pakai sebanyak-banyaknya, dan machine learning ini bisa tahu apakah data itu akan fit atau enggak dengan apa yang mau kita targetin. Misalnya di sini saya punya porosity, saya masukin porosity saya, lalu saya akan dump in a lot of cubes, a lot of drivers gitu ke dalam machine learningnya. Nanti dia akan tahu cube-cube mana, data-data mana yang punya hubungan dengan porosity dan bisa dijadikan guide untuk pemodelan porosity itu. Dan waktunya sangat cepat, karena kita nggak perlu lagi mikirin variogram, kita nggak perlu lagi memikirkan data preparation yang biasanya selalu kita lakukan di property modeling. Oke, jadi it's very simple, it's data driven, bisa handle banyak sekali input variables. Kita nggak perlu remove trend, kita nggak perlu, karena kode geostatistik, ntar kalian bisa cari sendiri, banyak sekali data conditioning yang harus kita lakukan. Dari removing trend, datanya harus stasioner, variogramnya, range, cell, nugget, segala macam itu banyak sekali parameter-parameternya yang harus kita pay attention sebelum kita pakai hasil dari data analisis itu untuk pemodelan petrophysical parameternya. Gitu. Jadi, then it's machine learning, jadi kita dump everything di situ, dia akan learn mana data yang cocok dan mana yang enggak. Saya akan tunjukkan couple of slides contoh gitu ya. Jadi misal di sebelah kiri sini ada target variabelnya. Di sebelah kirinya adalah true porosity-nya ibaratnya. Kita mau tahu apakah atribut-atribut yang kita masukkan di sebelah kanan ada seismic dari berbagai macam atribut. Yang bagian sini kenapa ada space-nya di sini tuh itu fault. Jadi ini section sebenarnya, terus diambil sectionnya terus di flatten semuanya. Jadi ini flatten version. Jadi kalau dilihat faultnya kayak gitu bentuknya karena memang di flatten. Jadi banyak sekali, jadi ada zone indikator, seismik, atribut 1, ada relative acoustic impedance, ada atribut 2, atribut 3, dan lain-lain. Dan kita mau tahu si machine learning ini bisa nggak sih dari berbagai macam atribut ini, mana ini hasilnya. Jadi di sebelah kiri itu adalah true porosity. Jadi true porosity kita dapat dari relative acoustic impedance. Jadi datanya ini ceritanya, skenario-nya adalah, ini udah ada papernya by the way, cuma saya lupa tampilin, jadi in case you need it, please contact me, saya bisa provide papernya. Orang Schlumberger yang buat papernya. Jadi di sebelah kiri itu true porosity. True porosity kita dapat dari relative acoustic impedance. Acoustic impedance itu salah satu parameter geophysics lah, you can find out about it. Jadi intinya relative acoustic impedance ini in this scenario it did a very good job in predicting the porosity gitu. Jadi korelasinya baik lah ceritanya. Lalu di sebelah kanan itu adalah hasil, jadi Ember, ini bukan Ember ya Pak. Ini Ember simulation. Jadi Ember simulation nama machine learningnya, saya belum mention dari awal, Ember simulation nama machine learningnya, dia bisa predict berdasarkan target porosity dari data sumur dikombinasikan dengan multiple parameter tadi, dia bisa predict di bagian mana yang punya porosity yang baik kayak gitu. Dan kalau dilihat di sebelah kanan, di sebelah kiri, kalau kita bandingin true porosity dan hasil Ember simulation-nya, it's done pretty good job gitu ya. It's done pretty good job dari correlation-nya, it's done pretty good job. Dan di uncertainty-nya bisa dilihat yang warnanya terang itu tuh yang uncertainty-nya rendah, yang warnanya gelap itu uncertainty-nya tinggi gitu. Jadi kita bisa tahu di bagian mana dia punya uncertainty yang rendah atau tinggi gitu lah. Jadi intinya adalah di machine learning for petrophysical modeling ini we go from a very traditional way yang butuh banyak sekali iterative process. Geoscience is a very iterative process gitu. Ke machine learning dia bisa learn by itself according to data-data yang kita masukkan ke situ. Lalu kita juga buat blind well test. Gimana cara blind well test? Intinya sih kita remove satu well dari dari pemodelannya, lalu satu well ini di akhir pemodelan kita mau ekstrak hasil model kita berhasil nggak mereflect blind well testnya gitu. Terus jadi yang sebelah kiri itu adalah, sorry for the noise, weekend agak rame rumahnya. Jadi yang sebelah kiri itu adalah actual data well-nya, yang di sebelah kanan sini adalah hasil dari pemodelannya atau dari machine learning-nya. Bisa dilihat dia bisa mimicking pretty good lah di situ ya. Oke. Terus sekarang ini tadi yang untuk machine learning petrophysical modeling. Oke. Terus selanjutnya adalah yang saya mau bahas adalah rapid screening. Nah, jadi di Delphi itu ada banyak sekali application gitu ya. Ada banyak sekali application. Salah satu adalah native application. Jadi native application di cloud environment Schlumberger itu adalah aplikasi-aplikasi yang dibuat khusus untuk cloud environment. Jadi kan ada aplikasi-aplikasi yang kita bawa tuh dari existing application. Contohnya kayak Petrel, Backlog gitu ya. Kita bawa ke dalam cloud environment. Tapi ada beberapa aplikasi atau dashboard yang experience-nya benar-benar kita bisa dapetin di cloud gitu. Salah satunya rapid screening. Rapid screening itu kalau misalnya teman-teman bayangkan satu company, contohnya ya, beberapa company yang operating di Central Sumatera atau di Kalimantan, kan biasanya in the development phase mereka punya jumlah well yang sangat banyak. Ya, mungkin satu aset tuh bisa ribuan well gitu. Dan seringkali isu yang muncul dari sana adalah bagaimana mereka menghandle ribuan well itu, bagaimana well correlation-nya, bagaimana secara efisien mereka bisa mendapatkan result yang didrive oleh data-data yang sangat banyak itulah gitu. Nah, rapid screening ini saya play videonya. Rapid screening ini adalah kayak seperti dashboard. Kalau kita punya puluhan ribu well, kita bisa filter out, kita bisa select misalnya according to the location, according to the name of the service providers, anything gitu. Yang terhubung langsung dengan GIS map di sebelah kanan sini. Kita bisa filter in, kita bisa filter out, kita bisa zoom in, kita bisa langsung cari, saya mau well di lokasi sini yang punya gamma ray misalnya. Bisa dicari langsung di situ. Kita bisa select, lalu kita log type-nya tuh, contohnya di select saya mau lihat yang ada gamma ray-nya aja, saya mau lihat yang di lokasi tertentu saja misalnya. Oke. Terus setelah kita buat situ, kita bisa bikin kayak studi overview-nya yang powered by TIPCO. Jadi kalau tadi lihat di slide saya tentang Delphi in a Picture itu, partner kita di data analysis TIPCO, Spotfire. Nah, ini powered by Spotfire. Jadi kita bisa lihat hubungan antara, ini masing-masing window ini akan menampilkan tadi well yang kita select sebelumnya. Terus kita bisa filter, kita bisa select juga di sini, dan akan terhubung ke masing-masing window satu sama lain. Jadi untuk analisa sangat cepat. Jadi misalnya kita mau cari well by Marathon Oil gitu, kita bisa select di window yang di tengah atas itu Marathon Oil, dia akan select on the fly juga di bagian cross plottingnya, di bagian histogramnya, di bagian mapnya juga gitu. Jadi saling terhubung satu sama lain. Even better, kita juga masukkan aspek artificial intelligence di sini. Jadi kalau misalnya katanya di sini saya bikin dari banyak well ini saya bikin satu cross section, terus saya mau sebarkan cross section itu ke well yang lain gitu. Saya mau korelasikan di cross section itu untuk markernya. Itu bisa dilakukan dengan machine learning atau artificial intelligence ya. By the way, jangan bingung. Kalau sekarang saya ngomong artificial intelligence, saya ngomong machine learning. Actually, machine learning itu subset dari artificial intelligence gitu. It's one of the parts of artificial intelligence. They create the machine that can learn by itself gitu ya. Jadi ini well correlation dilakukan dengan machine learning. Oke. Saya selanjutnya itu untuk rapid screening. Jadi gunanya kalau kita punya area dengan well yang sangat banyak, kita bisa analisa dengan sangat cepat, kita bisa automated correlate everything, kita bisa create surface, kita bisa quickly QC surface kita gitu. Itu rapid screening. Lalu selanjutnya ada di exploration. Kalau tadi mungkin well-nya udah banyak, lebih ke development atau lapangan-lapangan yang sudah produksi, sekarang yang lebih ke arah eksplorasi. Oke, tentunya di beberapa aspek ya, di berbagai macam development yang kita buat itu kita bekerja sama dengan klien untuk exploration ini, untuk explore plan, nama toolsnya kita bekerja dengan Equinor gitu. Jadi kita start di 2018, kita that was the first digital exploration collaboration agreement. Kita mau coba dengar sebenarnya dari mereka. Kira-kira kalau untuk exploration funnelnya Equinor tuh how they do it gitu. Dan kita mau dan dengan input-input yang kita dapat, kita mau coba come up with one solution yang kira-kira bisa relevan dengan proses exploration funneling di berbagai company gitu. Lalu di 2019, 2020 kita publish Explore Plan. For your information, Explore Plan sudah komersial dan sudah digunakan oleh SKK Migas as we speak. Itu jadi ini juga salah satu hal yang membuat saya sangat happy karena ternyata Indonesia itu jadi that was the very first adopter of Explore Plan di Indonesia, dan itu SKK Migas. So I'm very proud of it. You should be proud of it karena it shows that Indonesia we're actually way ahead in that case gitu. Terus yang lagi ongoing sekarang we try to connect people and competence, data and technology dan lain-lain. Jadi intinya adalah aplikasi yang kita create di sini we listen to our customers, we listen to the operators, we listen to the oil and gas players gitu, supaya ini bisa relevan dengan semuanya. Oke, jadi yang goalnya kita mau punya dashboard sebenarnya. Kita mau punya dashboard of exploration, di mana kita bisa melihat karena exploration itu akrab sekali dengan proses yang sangat tradisional lah ya. Jadi dan sangat tidak terdokumentasi dengan baik, tidak terkoneksi dengan baik, dan tidak bisa di-trace. Artinya gini, misalnya ada satu perusahaan, dia drill satu sumur gitu. Dia drill satu sumur, terus ternyata dry, taruhlah seperti itu ya. Kalau dry, terus dia mau coba cari, kenapa ini dry gitu. Dia mau coba trace back all of the processes behind that decision. Itu sulit. Karena seringkali proses-proses itu tidak terdokumentasi dan tidak traceability-nya sangat buruk gitu. Idenya dari Explorer adalah we can see all of those processes in one dashboard. Dan it's all connected to one another. Artinya, jadi contohnya gini, jadi dari satu keputusan untuk kita drill exploration well misalnya, pasti ada proses behind it. Contohnya, basin modeling, volumetric assessment, prospect assessment, play assessment, dan kalau teman-teman pernah dengar play-based exploration punya Shell, kurang lebih seperti itu. Jadi kita start dari basin, play, lead, prospect, then we come with the decision. The idea of Explorer Plan adalah kita mau record semua itu dan kita mau semuanya terintegrasi satu sama lain. Artinya, saat kita lihat, oke, satu well ini dry misalnya, then we can look back. Gimana sih petroleum system modelnya? Dia akan terhubung dengan Petromod. Gimana sih proses mappingnya waktu itu dia akan terhubung dengan project di Petrol. Gimana sih waktu itu prospect assessment dan dia terhubung dengan GeoX gitu. Jadi semuanya bisa dilihat di satu dashboard. Jadi nanti di satu dashboard itu juga terhubung dengan GIS-nya, kita bisa lihat semua knowledge background yang ada di situ. Kita bisa lihat semua event, kita bisa lihat, kita bisa assign misalnya satu exploration manager di assign satu project di basin A, team membersnya ada A, B, C, D gitu ya, project leadnya ada. Jadi semuanya itu sangat open, sangat transparan, dan bisa di track dengan sangat mudah. Itu idenya sebenarnya. Dan another very interesting thing adalah jadi di exploration itu banyak sekali proses. Seperti contohnya saya ambil contoh simulasi di petroleum modeling or basin modeling atau simulasi cekukan. Jadi dalam kita mensimulasikan itu, usually kita butuh engine yang sangat powerful. Kenapa? Karena ya, kalian bayangkan kalian mensimulasikan satu cekungan, satu regional cekungan sedimen dari top of basement sampai ke present day. Kalian mensimulasikan temperatur, pressure, migrasi hidrokarbonnya, mensimulasikan stratigrafinya juga gitu. Jadi you will need the cluster machine for it. Tapi no longer that case karena with the cloud computing, misalnya ada customer Schlumberger yang pakai service kita, dia pakai Delphi, dan the simulation will be run in the Google data center, which is beyond powerful. You will get limitless cores, you will get limitless engine powers. Artinya, at this point, as we speak, saya bisa aja run simulation dari handphone saya. Jadi kalau dulu saya ngebayangin kapan ya misalnya saya bisa buka aplikasi-aplikasi di cellphone saya, sekarang sudah bisa. Karena practically saya cuma butuh Google Chrome doang sebenarnya. Dan some remote desktop launcher dan saya plugin ke monitor dan I can work from it. Dan that's where we are now. Jadi kita no longer butuh mesin yang sangat powerful. Impact-nya apa? Impact-nya ke company-company adalah mereka tidak lagi harus invest di massive machine, hardware, dan segala macam. Okay, that's the impact. Then that's where their interest is. Gitu. Jadi they're interested to cut the capex, then digitalization makes sense in that case. Okay, that's the exploration. Yang terakhir yang saya mau tunjukkan adalah sorry by the way, I can make its own session for each of the example. Cuma karena we don't have a lot of time, jadi saya coba presentasi garis besarnya aja ya. Jadi gini, next example is seismic interpretation. Okay, seismic interpretation ini sebenarnya kalau kita bicara sedikit ke belakang, itu sebenarnya adalah salah satu proses yang kita coba benar-benar buat otomasinya dari dulu, dari automated seismic interpretation. Di Petal tuh udah ada automated seismic interpretation dari lama, cuma kan kalau itu lebih ke arah kita set interpretation parameter dan lain-lainnya gitu ya. Kalau di seismic interpretation ini, kalau di machine learning ini, jadi nantinya saat ada teman-teman misalnya you get to try Delphi environment di Schlumberger, saat kalian masuk ke Petrel, kalian akan punya opsi untuk pakai machine learning driven seismic interpretation, fault interpretation. Ada dua pilihannya di gambar yang di kedua, kalian bisa lihat. Ada pre-trained dan user-trained. Apa artinya? Kalau pre-trained itu, jadi Schlumberger globally kita ambil, kita bikin kayak dari 10 data seismik kalau saya nggak salah, publicly available, kita bikin machine learning berdasarkan itu. Jadi each of the seismic data, they have distinctive parameter gitu ya. Jadi it can represent a broad range of seismic data variation lah, saya bisa bilang. Nah, kalau user trained, kita yang melabeli itu sendiri. Jadi kita melabeli dengan, jadi ada dua namanya labels dan validation. Nanti saya jelaskan. Intinya kita kasih tahu si machine learning-nya kalau ini loh, saya mau pick patahan yang seperti ini, saya mau pick sesar yang seperti ini. In all of the seismic cube gitu. Please do it gitu. Jadi si machine learning bisa tahu, okay, then you're looking for this kind of features, then I'll do it for you gitu. Jadi fault extraction, segmentation sampai ke fault framework modeling. Saya nggak akan masuk lebih detail karena takutnya kalian lost. Cuma intinya di situ adalah kita mencoba mengotomisasi proses interpretasi seismik. Jadi kalau kalian ngambil contohnya mata kuliah apa dulu ya, struktur lanjut lah ya, itu kan banyak sekali. Gitu. Oke, ini prosesnya. Jadi yang warna biru itu adalah labelsnya yang kita kasih tahu di pick. Yang warna hijau itu validation-nya, kita masukin ke Petrel, kita masukin seismic datanya, then they will come up with the result, dan result itu bisa kita extract fault patches-nya, langsung kita bikin fault framework modelnya, kita bisa connect, kita bisa disconnect, dan lain-lain. Gitu. Jadi it will change from weeks to hours atau months to hours probably. Jadi lagi-lagi saat saya berikan semua contoh ini tidak henti-hentinya, it's all about time, it's all about the effort, it's all about the man hours yang si company ini mau expedite gitu. Mereka mau cut itu untuk lebih efisien lagi gitu ya. Dan untuk si automated seismic interpretation ini ada, kalian bisa search, ini kayaknya semua videonya available di YouTube, dari mulai yang atas tuh Woodside Executive discuss about the field development planning, Intex, digital formation, Petrus Schlumberger, transforming field development, Chevron, Microsoft, dan Schlumberger announced collaboration. Jadi these companies they're moving very fast gitu. Dan the question untuk kita adalah whether we're in or out gitu ya. Yang di sebelah kiri bawah juga itu ada SS Global Forum di September 2019 kemarin di Monaco. It's one of the biggest event yang pernah ada. Itu juga kita banyak diskusi tentang digital transformation di situ. That's the main focus. Jadi this industry is moving very fast towards that direction. Saya udah jelaskan background-nya apa, saya udah jelaskan ke teman-teman drive-nya apa, dan it's happening now. Jadi ini bukan sesuatu yang akan happen di next year atau months from now, no, it's happening. Jadi kita harus siap, kita harus punya muscles-nya lah as geologist. Terus with all the achievement, with all the processes, with all the discussion, with all the yang udah saya jelaskan tadi, how are we doing? Jadi untuk sesi processing, you can see the numbers, 13 to 2.5 months. Well intervention, 80% efficiency. Structural adaptation, well construction, simulation dari 120 ke 3 hari. Field development planning, dan ini saya baru kasih contoh dari segi geoscience-nya. Ada banyak sekali, dari mulai reservoir engineering, liberated engine, agile reservoir modeling, ke production, ke surface facilities, semua banyak sekali range-nya gitu. Jadi ya dari yang saya tunjukkan ini baru sebagian kecil dari total of, I don't know, banyak sekali solution gitu ya. Jadi this will be my last slide. Jadi pesan saya sebenarnya, despite of semua yang saya jelaskan tadi soal artificial intelligence, machine learning, dan contoh-contohnya di geoscience, believe me, nothing can replace geologist intuition. Jadi jangan the way we take it, jangan kita jadi karena we're moving towards the automation dan kita tidak akan dibutuhkan lagi sebagai geologist. No, it's not the case. Dengan adanya ini, kita sebagai geologis, bukan hanya kalian, termasuk kita harus lebih open-minded, kita harus lebih aktif, kita harus lebih cepat lagi, keep learning, karena banyak sekali hal yang learn in this situation, banyak sekali hal baru yang bisa kita learn. Geologist and as a human being lah gitu ya. Jadi itu aja presentasi saya. Terima kasih untuk waktunya. Saya kembalikan ke moderator.
Thank you so much, Mr. Lutfi Nugrahadin, for the keynote speech. And I would like to highlight something from the presentation, that nothing can ever replace a geologist's intuition. Okay, so now we will proceed directly into the second session that will be presented by our second speaker, Mr. Sashi Gunturu, the founder of Petrabytes, which helps oil and gas companies optimize drilling and production operations with proprietary cloud and edge computing workbench, Blue Grids. Prior to Petrabytes, Sashi worked as an independent project consultant with Reservoir Technology Group at Baker Hughes, and in different roles with Geomechanics International, including upstream software development and consulting in the areas of well planning and geomatics. Mr. Sashi received his Master of Science in Petroleum Engineering and Master of Science in Computer Science from University of Tulsa, Oklahoma, USA, and Bachelor of Technology in Chemical Engineering from Andhra University, India. Mr. Sashi is a member of AAE, Alliance Technology Entrepreneur, Open Houston, and TIE Houston chapter. And now I would like to welcome you to join us on the stage. Good morning, sir. How are you today?
I'm good. Thank you.
Glad to hear. All right, sir. To save up our time, you can start your presentation now, and the floor is all yours.
Thank you. So can you all see my screen?
Yes, we can, sir.
Yeah. Yeah, thank you all for inviting me, and that was a great presentation. So mine will be just a reinforcement of what Mr. Lutfi has talked about. So thank you all for joining today, and thank you for giving me this opportunity. So my presentation will be to focus on what is that you as students, and because I was in your shoes 25 years ago, and what is that you can do in order to catch up with the fast-moving industry with all the digital things that are happening in the oil field. So I'll focus on more on what you can do from the cloud technology point of view, how you can get started and things like that. And then I'll give you a perspective from the technology, what's happening with the cloud computing, with Microsoft and what they're doing. And then I will try to link both the worlds of both the technology and what you can do with geoscience. So if you look at, this will be my presentation overview. We'll talk about the subsurface complexities and how the computing has evolved over time in the last 10 years and what is really causing this rapid change. and then mainly dealing with real-time data analysis, like if you're getting data in time with all these sensors, what can you do? And then look at the data transmission standard and how you can improve the analysis. And then we'll talk about a little bit of machine learning and then cloud computing infrastructure. And how does, because you have lots of data from different sources, so what does subsurface data engineering look like? And I'll talk a little bit more about real-time modeling, because that's where, like the previous speaker talked about how you are reducing from several months to days. Now you're looking at, in few seconds, what can you do in terms of real-time drilling and any kind of production optimization. So this was a comment that was made a few days ago, or a few months ago, by the industry voice, that talks about with this extremely low market conditions and also with the COVID-19 that has literally brought the entire world to a standstill. What is really driving the oil field, right? If you look at the digitalization of all the assets and machine learning, those are the things that are driving the industry right now. Like it's unbelievable, like people communicating with Zoom and then connecting throughout the world, like just a few months ago, but now this has become a norm. So the digital space, what is accelerating the oil now. Traditional subsurface challenges still remain. Like if you have different geological basins, you have continuously growing data, you have data in different locations, and you have sequential, like geophysicists, geologists, drilling, all working in sequence. And like the previous speaker talked about how we are coming up with an integrated environment to address that sequential and also the discontinuous workflows. And if you look at some of the challenges with data, the subsurface data, the reason why OSDU, one of the main goals of Open Subsurface Data Universe is to make sure that when people are building software or exchanging data, they do it in a standardized way. Like you exchange information with APIs, which is the application programming interface, so that the end application, you can have like a C# program that can interact with the Java program, irrespective of how it is written. That way you have a standard of exchanging the data and also how you represent the information. So the OSDU was primarily formed to address this issue, like unstructured data, structured data, and the proprietary data formats that people have, and also the proprietary databases. So once you have all of these, you are now putting it all together to come up with an integrated way of exchanging information. Can you hear me okay? I see a lot of disturbance. Can you hear me okay?
Yes, now the voice is clear, sir.
Yeah, okay. And then you have different data types all the way from seismic, geology at the field level, and then the well level you have faults, horizons, and then all the multiple wells and core sample sections. And then you have the sensor data, which is where now instead of looking at point sensors, now you have continuous fiber, which is like a continuous sensor where you're getting 1 meter resolution. And some of these data sets are almost, you're getting like a few terabytes a day. So it's pretty significant. So the data management, the computing, all of those come into play when you're implementing the solutions or when you're developing any kind of integrated analysis. When it comes to real time, you have continuously growing data, you have sluggish remote connectivity, you have time constraints for efficient analysis because you have to do it fast. Like some conventional place in Texas, they have to drill within like 6-7 days, and they have to move on to the next well. So now with the reduced price and very stiff market conditions, so time and efficient analysis is a very big challenge right now, and you have to do it at a very low cost. So, and also, as I mentioned, limited staff, and then the whole logistics cost, like how do we drill faster? How do we drill cheaper? Can you automate any of these processes? So the data after interpretation from several days to months or several months to days, now we are looking at almost real-time, instantaneous information that you need to analyze. Then you also look at continuously data, like as I said, the sensor data sets, like acoustic sensing. It has a big play right now in different, not only in wells, but also pipelines. It has rail monitoring. There's a lot of things that are happening with the sensing of information, with this distributed sensing. It has temperature sensing, vibration sensing, acoustic sensing. So this could be also a replacement for the vertical seismic profiling, the VSP. So that is like almost getting 40 seismic every month. So this data is really becoming bigger and bigger by the day. And then if you look at the hydraulic fracturing, this DAS monitoring is really being used right now to monitor the fractures, how fractures are propagating, and what is the efficiency, in which stages are more efficient. Then you still have the challenge of the sluggish remote connectivity. So that's where the edge computing comes into play, because not every device can be connected all the time. So you have to have edge computing devices. Has the intelligence to implement those. So all of this, we talked about the subsurface challenges, we talked about the real-time connectivity, we talked about efficient, like the data challenges and all of that, right? So how does computing come into play, right? So what has happened in the last 10 years is, previously in early 2000, you had like client-server applications, and then you had the whole concept of big data coming into play with Hadoop, where you have distributed clusters, all of that. So setting up this cluster was also a very big challenge, and making sure the nodes don't fall off. There's a data node, there's a driver node, there's a worker node. So in order to distribute and like you could do a seismic processing on a server. Let us say you have like 10,000 machines. Can you do it faster? So there were a lot of things that happened during the early 2000s, and also in the computer industry, where you had the client server app. So over the last 10 years, see the cloud micro. So everything is like a managed service. So you don't have to worry about how to create a cluster where you have a distributed computing environment, and you don't have to worry about installing software. Everything will come as a managed service. So that's where in 2016, when Microsoft CEO took over, his main theme was cloud first, mobile first, right? That was the theme. And then Amazon, the lead with all the government projects, and then Microsoft and Google accelerated with machine learning. So from basic client server applications, it has moved to managed service in the cloud. So all you need is just a browser, and you can code, you can deploy, everything can be managed pretty much using a web browser. All you need is just an internet connectivity, and you don't have to worry about the infrastructure. And that's what the previous speaker was talking about, how the cloud is really changing the game of processing power. So. And more importantly, the cost also, you just pay per use and pay per compute units. So, and then you can scale up the cluster. So if you want to process, say, 50 terabytes of data, you can set up a cluster within like probably a day, and then just run it, and you can process that entire data. Whereas in just a few years ago, you had to have a big infrastructure of a big Hadoop cluster. All of those that would take several days, if not weeks, to get up and running. And then the compute power was also problematic to maintain that infrastructure. But now everything is a cloud managed service, so everything is delegated to the cloud providers, and then you have the infrastructure that is all scalable, so you can shut down and you can have more clusters or more nodes to do more faster computation. And then you pay per use. Once it's done, you just shut it down, and then you can use it. So that has significantly changed the whole game of scientific computing. So now, if you see the OSDU, who are the prime drivers? It is the oil companies, and it's the tech companies. It's Microsoft, AWS, Google, Oracle is also joining. So all of these players are the ones that are actually driving the scientific computation. So the geological domain knowledge is there is a convergence of geology, geoscience, drilling and production engineering combined with the cloud computing. So that's what is accelerating the whole discovery of or realizing the hydrocarbon efficiency. So if you look at how do you process all of this data, right? So for all this, whatever we talked about, identifying the factors, like the previous speaker talked about data, right? So if you have so much data, how do you process? So you need a data engineering implementation. So you can use Spark cluster, you can use different data pipelines, and then you can automate this whole process. Like let us say with whole DevOps, so that means you create a new feature and you immediately deploy. You don't take like 6 months of release cycle and things like that. So everything is continuously evolving. So you're getting faster rate of returns. So these days, if somebody approves a budget of say $1 million, they're not going to wait for 1 year to get the recovery on that money. They want immediate results. So that's where this continuous deployment comes into play and continuous delivery. And then you have this big data computing at scale. You have Amazon has its own service where you have different data pipelines. Same thing with Microsoft. So you have data pipelines, you have automation, and also connecting different systems through API, and that's where OSDU comes into play. So you have the compute power, you have the cloud infrastructure, you have all the data pipelines, and then you have the whole machine learning layer that is coming into play, and then you are doing a lot of computation at scale, and also not only just computation, you can deploy this whole application across different business units. So if you have a new seismic attribute calculation, you can now deploy all over the place in the cloud. And that is the reason why the pace of computing is really driving the whole discovery of the hydrocarbon reserves. You know? So this is a typical example of the distributed computing where you have a Spark cluster, there you have worker node and all of those. And then you have different kinds of cluster configuration. So you have memory optimized, you have storage optimized, you have compute optimized. Let us say you're doing a lot of seismic attribute calculation. So you could have if you want to do it faster and you're doing a lot of data visualization, you can have a memory optimized infrastructure. So that way you can do everything in memory. So that's the whole part of Spark infrastructure. Okay, and then you have the GPU based computation also for large scale visualization and things like that. And this is an example of how you distribute your jobs so that you can compute faster. So you can read up all of these. So these are the building blocks of how you can do distributed computing. And then it has a rich ecosystem of programming languages. You have all the way from Scala, Java, Python, and R, and all the things that you can have. It has a rich support for all the programming languages and also machine learning. So this is really taking over in faster processing of data. So in addition to doing all the seismic processing, all of that, right? Newer data sets like the data from sensors, all of those are coming in, right? So now you have a much bigger data set to process, and then you want to do in a much faster way through distributed computing or through the cloud interface. And then you want to not only do the data processing, but you want to do the analysis and also deploy across business units. So what you are providing, the cloud has given you is all the way from raw data to insights, the complete end-to-end ecosystem of microservices. And then you are building new applications on top of it, like Delphi or the things like Blue Grids we are building on. So those are the domain-specific intelligent applications. But then the cloud is really accelerating the whole end-to-end workflow. So then there have been a lot of improvements in the data transmission standards and techniques. So for example, Energistics has standardized how you move the data, like WithML, ProdML, all of those. And then there is Energistics transmission protocol. So this is providing you the stream of mechanism. Like for example, if you're looking at a Netflix movie, you're streaming, everything, the frames are streaming, right? Similarly, if you have lots of seismic, you can stream data, just like a Netflix movie, right? So those are the kind of things that are looking at. And then just like how you have a discovery mechanism, like you can subscribe to a service. Let us say you're mine wells, you can subscribe to a real-time service. Just like you have a WhatsApp group, right? So you have multiple people logging in, anybody puts a message, everybody gets that, that information. So you now have the subscription services, microservices that you can have, where you can have continuous monitoring of the assets without need to poll for getting that information. So in summary, what is happening is the transmission of data from the well site to a location where you can analyze it faster has improved. So you have edge that does a lot of computation when the data scale is bigger. Like if you want real-time monitoring centers, the data, that's where you are using ETP and all these efficient transmission protocols for the data. So this is a higher level architecture where you have just like an API mechanism, you have bits enabled clients, and then you're getting the data through an XML or through JSON. So the idea is this would be one of the fundamental layers of OS2. So when you have two disparate systems, each one built like one can Fortran program and a legacy system, another one is a more modern system, without having to connect all this information, all these applications together into one giant application. You can keep the application wherever they are, and then you can exchange through an API. And when you exchange the information through an API, you through a standard. And that's what the OSDO ecosystem is doing. It's giving you the standard. You exchange the information through a standard set of APIs and a microservices, and all of that, all the cloud infrastructure to do this transmission. Okay. Then there are companies that are providing compression of the data. So if you have large-scale seismic, how do you create data? So you have the VDS system. So the idea is to minimize data duplication during the and only transmit the rich data during for processing in the cloud. Then if you look at the machine learning, there are so many things that are happening, but I would like to just summarize what really qualifies a good approach. First thing is you need a lot of understanding of the data. You need the domain knowledge. You need the geologist. You need the geophysicist. And not all business are machine-related application. Okay, majority of them could be, but then some probably a technical computation issue. Some are basically a statistical problem. You can't say everything is a predictive application. So you have to decide what is actually a machine learning problem and which part of the machine learning can really accelerate the application. Then you need to understand the business problem. So all of this requires the domain knowledge. Like what are you really trying to solve? Is it a pore pressure problem? Is it a drilling problem? Is it a ballooning effect? So you need to really understand what is the kind of physics behind the problem. Okay. And then if it's a predictive model or is it just a simulation or a mathematical model? Is it an analytical solution? Is it really a predictive model? Are you going to use data to really come up with a solution? Are you going to simply simulate like using a Monte Carlo simulation, or is it just a mathematical correlation? Okay, so you need to understand the science behind the problem. And then whenever you have the solution, do you have enough data to model? Because most of the time you don't have the data, right? And also the quality of the data. So these are the things that you need in order to build a better, efficient machine learning models. And also, when you talk about, let us say, like predicting the flow is one of the difficult problems. Okay, you can say where the fault locations are. You can give a probability of failure like P10, P90, and all of that. But actually predicting the exact flow from any reservoir or any well, it's not easy, especially at the zonal flow. So in that case, you have to set the expectations. So you have to do, it could be like there is a margin of error and things like that. So the machine learning should be adaptive. It cannot be definitive all the time. So it has to learn continuously. Okay? And then if you have to look from other industries. For example, in the medical industry, just like a seismic imaging, you have lots of other images like like what is a cognitive impairment, like this is an image from the Alzheimer's. So a lot of things like what we apply in the oil field can be related to the medical field because it looks at high resolution images. And these are being applied to human beings, right? So these should be really, really accurate, right? Than the seismic interpretation that we are doing here. So in fact, one of our main 3D specialists comes from the medical background. So he has a doctorate in biophysics and worked for the Baylor College of Medicine. And then he now does seismic interpretation for us. So there is a lot of parallels from the medical industry that can be used in the oil field. So if you look at websites like Kaggle, where you have a lot of examples, if you look at some of the radiology images from Yale and any of these public data, you can see a lot of information how you do feature picking, like the previous speaker talked about how you are picking faults and all of those things, right? So a lot of these information can be used from the medical industry in terms of identifying, like here, if you're looking at Alzheimer's disease, you're looking at the left brain, the right side of the brain, the fluid inside the brain, all of those things is what you're looking at. Here also you're looking at where are the faults, where are the horizons and things like that. So there's a lot of things you can learn from the medical industry. And if you look at Uber, especially in South Asia, right, like in India and all the places where you have the geographical location is not exact, so it is constantly learning. So for example, if you go to any remote place where Uber has never given you a service, so as soon as you register, it will learn. So it has given you a lot of, so Uber has a platform called Michelangelo, which has the machine learning framework. So it divides the whole framework into multiple layers. So for example, data moving capabilities, like you are moving from point A to point B, and there has a separate set of applications, like a microservices, and there is data preparation functions. Then there is ETL, which is extraction, transformation, and loading functions. So, and then there are training functions. So, and then there are streaming functions, like if you have streaming data, like real-time data, you have that. And then you have serving functions. So they have divided the framework into multiple layers where you can, depending on the need, you can use those microservices. So this could be a good reference architecture that you can look for how Uber does that. Like for example, if you have a car, it says now if you're looking for a ride, it says so many cars are available for your ride, right? Similarly, you can say how, if you're getting a flow from a well, you can look at how much interference you have from the neighboring well. So if you have data like that, right? So there could be a lot of parallels between different industries that you can apply to the oil. And that is the reason you have a lot of tech companies, like the previous speaker talked about Tableau and Tibco coming up. They actually came up from the tech industry, from the Silicon Valley, right? So that's where I think the biggest thing that is happening in the oil field is the convergence of the oil field domain knowledge with the tech industry, and that's what is accelerating this whole digital journey. So we talked about how we do the modeling and all of that, right? Now, how do we make the real-time data? Because the data is becoming more and more, and people want instantaneous results. If not real-time, they want relevant times. Like, for example, from multiple days, they want in hours. Okay, so you have to have a lot of fast computations. Okay, so first thing is you need the large-scale computation capabilities at the edge. So that's where the edge computing comes into play. Then you need to have access to the subsurface models. Then you need to have dynamic workflow. So let us say you have a seismic attribute that is updated. The same seismic model should be available to the driller so that you can have better side tracks and things like that. Okay, and you should have the ability to perform a lot of what-if scenarios. Like you should be able to quickly calculate, change the permeability, and see how does the skin change, how does the production change, how does the nodal analysis change, things like that. So you need all of these are the fundamental building blocks for any kind of efficient real-time data analysis. And then you need the connectivity from edge to the cloud. And then you need to have access to multiple specialists across different locations. And then you need to have that unified portal, which we talked about, the previous speaker talked about that. So why do we need edge computing, right? So for example, this is an example from a hydraulic fracturing that you see. What you see here is the spectral energy across the perforation clusters. So you have a lot of noisy data, right? So if you look at this, I don't know, the video is not playing, but you have, so the idea is you are getting lots of data every second. So every second you might get up with 5 gigabytes of data. So in this case, the blue is all the noise that you have, and you are eliminating that noise. Okay, and that is the reason why you need that efficient edge computing. Now, as you can see, I'm playing over time. You can see how the spectral energy is changing over time. Okay, this is the acoustic signal that you see during hydraulic fracturing. And then when you apply all the data cleansing, everything at the edge, so that's where you see. So now I've removed all the noise, and I can only get the edge, the more what is the relevant data. So here what you're seeing is across the perforation cluster, how is your acoustic signal changing over time. Okay, so the edge computing brings you the efficiency of computing everything at the well site or at the location instead of transmitting all the data into the cloud. So you can't be transmitting like terabytes of data into the cloud because you have low network and it's expensive to transmit all that information. So that's why you need the power of edge computing to cleanse all this data, and then you can do a lot of analysis at the edge itself. So the cloud providers have actually provided some efficient edge devices, like AWS has a snowball edge. It is ruggedized. It's just like your big suitcase. You can throw like 80 terabytes of data. It works below water, and it's all pay per use. Same thing, Microsoft has its own solution, and then there are a lot of IoT devices that you can utilize. And typical applications would be for seismic and acoustic sensing, where you have lots of data. Okay. And as I mentioned, the continuous integration of real-time data and dynamic updates of the workflows, that is the crux of what the cloud computing can achieve. So if you update your seismic profile, you should be able to now derive properties along the wellbore. If you update your well trajectory, you should be able to get new kinds of rock properties or wellbore stability calculations along the well. If you update, if you drill into a sidetrack, if you're stuck into the problems, you need to be able to do a lot of what-if scenarios for different trajectories. Same thing with production, like how are multiple wells, where is your next well, what is the well facing, all of that, right? So all of that is possible only when you have the continuous integration of different disciplines. And that's where the cloud comes into play, because you have an aggregate data store, efficient, cleansed with all the data pipelines, the previous steps I showed you. And once it's all there in the cloud, then you can apply your analytics like machine learning and things like that. Then you can come up with better geological model, 3D permeability model, 3D porosity model. And not only that, that model can be available to all these drillers and production engineers. So for example, a completion engineer can now access seismic. Previously, that used to take months to access the information. Now it's all there in one platform. So the continuous interaction between applications and also that access to the subsurface field models and interlinked workflows, that will improve the efficiency in terms of modeling. So that's what is the rapid change in the last 3 years. That integrated workflow all the way from exploration to monitoring, and that has been made possible by the tech industry and the embracement of cloud computing to provide that unified integrated asset. So I'll just briefly talk about what are the essentials. So you have the structured data, unstructured data, you have microservices, data pipelines, in-memory clusters, relational databases, and binary storage formats. And then typically people aggregate into the cloud. And then you have this field level data, right? All these things. And then here is where you have the connectivity from external resources like OSFI, the historian, also the OSD. So that is how you have the data being transmitted to different applications through a standardized interface. Okay, so these are some of the real-time cases, as I mentioned, multiple workflows. So this is an example of how you would do multiple data pipelines, all the way from well data, well log data, core data, formation tops, subsurface data like horizon surfaces. All of these can be done through a data factory, which is again a cloud microservice. You can go into a staging folder and you can process all this information on a cluster. So this would be a typical data engineering workflow. Okay? So, and then you can build contextual dashboards, as the previous speaker talked about, right? Where you can link the machine learning. How does it apply the new formation tops by looking at the geomechanical model and the subsurface model, and then these are the well locations. So you can build this contextual analysis. Okay. So this is an example of offset wells, how we have well locations, drilling data, and also the 3D visualization of the geomechanical grid. So. And these are the examples of rock properties, how you can compute different rock properties dynamically as you are getting these workflows. And then the previous speaker, as he mentioned about the adaptive learning, right, the machine learning. So you can take from seismic to all the fault picking and essentially build the 3D subsurface model that can be used for potential pay zones and identification of that. So again, as he mentioned, we are reducing from several months to few hours, or a few days, but probably few hours. You can do a lot of computation. And the faster the model is constantly being trained using the machine learning, right? So every time you have a better data set, the model updates itself, so you have a better pick. So, and that's what the cloud is enabling you. It's not only building the model, but also deploying it at scale, and then making it accessible to all within the so integrated sub. You have the GIS, you have analysis, 3D properties, the 3D memory of surface, statistical models, and then you have the map analogy, and then you have all these. Then you build the fields, do any kind of mechanics, all the flow analysis, like which zones are producing for production and so on. So that's a summary of what I wanted to talk about. Like, how do you take these tools and how do you apply for the subsurface, or which would be geological and geoscience modeling. Okay. So as a company, what we do is we provide that kind of a data engineering and governance. We have the platform. So our goal is to take from data to insights all in one unified platform. Okay. And this is my contact information if you guys need any questions. So that's a brief summary of what I was thinking, like you guys can work on. And again, there is a lot of public data that you can utilize. Like, for example, Equinor has donated the WALL data set, which is a 3D subsurface data set that you can use. It has all the wells, seismic, horizons, all of that. That can be a good good resource for analyzing the data. And same thing, UK oil and gas sector has released about 130 terabytes of data. Again, I think you have to have some kind of registration, but all the data is accessible. It has about 12,000 wells, so you can do a lot of learning and machine learning on top of it. So what we have done is we have taken that data into the Blue Grids platform, and then we are building on top of it, and we are making it accessible to students and early adopters of the technology. Okay? So if you guys need any kind of information, please contact us. We'll be happy to help. So thank you all. Again, thank you for your time, and thank you for listening. And then let us know if you have any other questions. Okay? Thank you.
Thank you, Mr. Sashi Gunturu, for the keynote speech. And ladies and gentlemen, we now have entered the discussion session, and you are now allowed to send your questions in the comment section, and don't forget to address to whom you are addressing your questions. So we will now wait for the questions from the comment section. Okay, so maybe for the first question, I would like to ask something to Mr. Lutfi. Sir, how do you project the future of geology in this digital era, and what differentiates it with other practitioners in different backgrounds?
Oke, jadi gini, jadi memang ya, kalau kita bicara tentang peran geologisnya, I think it will still be significant. And for your information, companies are still looking for the best talents. Jadi we'll still need regeneration, especially in this very saturated industry lah ya menurut saya. Jadi kita masih butuh banyak brilliant young talents, especially geologists. This automation stuff, this machine learning, artificial intelligence, and all sort of things, menurut saya ini, let's see it as a tools to help us gitu. Jadi jangan melihat ini sebagai sebagai replacement dari si geologis itu sendiri. Jadi kalau in other spectrum of domain kayak misalnya and it happens to, and actually it's a good question, dan itu bukan happening di geoscience doang, jadi itu juga happening di reservoir engineering, it's happening also in the production engineering, surface facilities, and all the chains, it's all happening gitu. Cuma as a geologist, menurut saya takeaways-nya adalah we have to adapt to the situation because the market trends, it's all going there. All the companies are looking to strengthen their portfolio. It means they want to cut the capex, opex, they want to be more profitable than ever, especially in this very harsh situation with the oil price and the pandemic. Then if we look at the market outlook next year, I don't think the oil price will go beyond $50. So as a geologist, again, it is very important to get good muscles with all this change happening, and dan yakinlah kalau perusahaan-perusahaan ini masih butuh brilliant young talents kayak kalian gitu. Jadi that's my message.
Okay, so to conclude, in the upcoming days or even years, geologists are still needed in this, even in this digital era gitu ya Kak.
Yes.
Okay, thank you so much for the brief answer. And maybe since none of the attendees are asking more questions, I would like to ask something to Mr. Sashi. Sir, can this cloud computing be applied to something other than oil and gas industry, especially speaking in the geological sector?
Yeah. So apart from the traditional upstream, so if you look at the midstream, where you have the transmission of hydrocarbon, there's a lot of cloud computing happening there, especially with the midstream, like hazardous materials, for transmissions, all of that, right, where you need continuous monitoring. So the fundamental physics of flow and the flow modeling, and then the stability of any asset, whether it's a pipeline or whether it's a downhole well, the fundamentals are the same, pretty much. The physics are the same. So that is where the cloud computing is going. And also in geothermal, there's underground storage, there is geomechanical modeling going on there. So it's not a traditional oil and gas, but that's where it's happening. Also with every company trying to be carbon neutral, there's a lot of computations, like methane detection is another big area that is happening. So there are extended applications beyond oil and gas that are being seen, where you read a lot of computations, not necessarily cloud computing, but science, newer applications or newer analytical solutions. And on the cloud is also taking that. That's all.
Thank you, sir, for the very brief answer. And now there are questions from the participants. The first one is from Andi Zulkarnain. He would like to ask Mr. Sashi, I am curious, how do we determine that cases from other industries are similar to drilling data? Do we observe the similar data represented, or are there certain parameters that are similar between the two industries, for example, between oil and gas and medical science?
Yeah. Uh, Two specific examples could be like the feature recognition, like feature detection. Like if you look at any brain scan, like if you look at the brain project, looking for certain areas where you are seeing a clear contrast. Same thing with the seismic too. You are seeing where is the seabed, is there a clear fault depiction, things like that. Right? So the feature extraction concept is very fundamental. That is similar to both medical industry and the oil field. The other thing what you can also look at is, for example, missing data, like filling up missing well logs, right? So this is a typical statistical thing that you or any kind of stock market analysis or any kind of like fundamental machine learning problem where you're looking for probability of failure, missing data, those fundamental concepts are applied throughout the either financial or medical, even like sales projection and things like that, right? So those parallels can be applied for the oil field too. Like for example, well log detection, like depth stretching, identifying, like simulating the well logs, all those things, right? So those are fundamental machine learning things that people have grabbed from other industries, you know. But one strike with the feature detection, feature picking, that is significantly the seismic and medical imaging, they go hand in hand.
Okay, thank you so much for the very brief answer. We hope that it answers Andy's question. And now we would like to ask the second question by Melissa from ITB. To both speakers, what would you suggest to people who are totally unfamiliar with machine learning and cloud computing? What would you suggest to us to learn first? Maybe we could start with Mr. Lutfi, the question.
Okay, good question. Sebenarnya kalau kita lately bahkan kayak saya lihat ada beberapa speech soal AI, and we can join it online for free, right? Let's start from there. Then, by the way, you're not alone. Banyak, and I'm not only talking about students, also my clients in general. For example, not all the communities, and I myself, I don't understand deeply about the mech behind it yet, not yet. So we all keep learning. The learning curve is still happening. Let's start from taking the short sessions, knowledge sharing sessions like this. There's some other free sessions, I think, dari khusus untuk community artificial intelligence and all that, yang bisa kalian join join, lalu take short courses if possible. I think a lot of courses in coding, data science, whatever. Then if you're interested more about it, then be serious about it. Terus ikut ambil education lagi untuk itu. It's all possible. Then at this time, kayaknya at this situation, learning itu dibikin tidak terlalu sulit lah kalau menurut saya, karena there's a lot of sources yang bisa kalian pakai gitu. So that's my answer.
Okay.
Yeah, I think it's yeah, thank you for that. I'll just add few comments on top of it. So first thing is look for like courses, like Google has a crash course on machine learning. So it's very nicely explained, simple concepts.
Yes.
Then understanding the statistics, like the basic math and statistics are very important for thing. And then Python, right? Python is like the new MATLAB for any kind of research. So there are plenty of examples all over the place. Use public data for use Python. I mean, there are so many examples that you can use. Python and then public data and looking at these machine learning courses. I think the Google machine learning course is pretty good. It gives you very simple, straightforward examples to get started. I think you but don't forget the physics. Like, what are you trying to solve? And I think the more hands-on you get, you see a lot of geologists are now taking Python programming lessons. So I think it's getting hands-on would be very helpful. And ML flow is another example where you can look at the machine learning deployment. That will be very good also. But all of these will come in play. Like, if you see all the distributing, the Spark fundamental thing is now PySpark, like Python applied. So I think Python will go a long way in getting getting problem to the end much faster.
Thank you so much,
And
sir.
it has a lot of built-in libraries too. Like, if you want neural networks, if you want a linear regression, all of those there are a lot of built-in libraries. So you don't have to really invent anything.
Okay. Thank you so much, Mr. Lutfi and Mr. Sashi, for the answers. And we will now proceed to this third question from Alfar Fadil. The first one is, generally, digitalization and technological development will be more efficient in the funding and time needed. Does this mean that less will be needed? And does this mean that big companies will have a relatively more thin structure in the upcoming time?
That's a I'll let you go ahead. Then I'll
Okay, so
talk about
Mr.
it.
Lutfi can answer first.
So yeah, jadi just to share a little bit, I think I also said this at the beginning of my presentation. During the 8 years of my time in Schlumberger, we've gone through three very huge reorganization. We keep thinking on how we make things more efficiently, and we want to cut off a lot of bureaucracy, a lot of reporting lines that we now are very slim and compact. It will allow us to adapt faster to changes to our local customers, and it will just give us more space. But does it mean that less people need it? Well, it depends how you look at it, right? But what I can say that every company, not only Schlumberger, every company is looking to do things more efficiently in terms of costs, in terms of gain more profit, for example. So yeah, that's my answer.
Yeah. So just to add to it, right? So with all these things that are happening, there is always a worry about job security and things like that, right? So as long as you're always learning, I don't think you should be worried about whether AI is going to cut people. So AI will only benefit the efficient way of doing things. The science will never go away. So science is fundamental, and then comes data science, right? So as long as you're constantly learning, you shouldn't be really worried about anything else.
Okay, thank you, sir, for the answer. And there's a second question from Alfar, which is, generally, who will run artificial intelligence in the oil and gas industry? And will there be more geologists who learn science, or will there be more data scientists who will learn geological sciences? And as for fresh graduates, which do you think is best?
Shashi, do you want to take this one first?
Yeah, that's a very good question. I would think so. The business has to see the return on investment. Just because other companies are doing AI or it's a buzzword, if people take up that, then it'll be a failure. So they need to understand the business problem. So I'm seeing situations where it is driven by the business, where the asset team as a team is looking at the problem. So it's not just the data science or anybody else. It's the geologists, geophysicists, drilling and production engineers, plus the data science who is strong in math. I think technically everybody is strong in math. Everybody is trying to understand the problem. So it is the integrated asset team that is looking at the data science. I mean, bigger companies like Schlumberger or probably Exxon, they're probably having their own data science team that is looking at not just oil and gas problems. They're probably looking at supply chain. So they have a much bigger agenda for the team. But if you're directly applying for specific asset, they're looking at data science as an integral part of better efficient analysis. It's not something separate.
I think I agree with that. And just to add more stuff, if the questions who's going to run the AI in oil and gas industry, it's almost everyone, right? Every of the domain technical space, we have geologists, geophysicists, engineering team, reservoir engineer, production engineer. Then just to reiterate what Shashi has mentioned just now, that yes, we do bigger and more complex companies like Schlumberger, we do have our own data centers. We hired a lot of data scientists. We hired a lot of the engineers to work on stuff to see the market beyond like 5-10 years from now. So yeah, almost in every spectrum of the personals, they're using AI. So not only geologists.
Thank you so much, Mr. Lutfi and Mr. Sashi, for the answers. Now we will proceed to the next question from Engel. Before Engel, say thanks for the two speakers for the exposition. And the question is, what are the application of machine learning or AI in the hydrogeological aspects? From what I learned from the lecture, hydrogeological modeling seldom depends on mathematical approach, and mathematical approach has its flaws too, mainly based on simplifying things with some assumptions. What are the examples that the two of the speakers are already encountered while working in the AI sectors?
I haven't worked much on hydrogeology, so skip the question. So.
Well, yeah. To be honest, I haven't worked much as well with the other geological, but to be honest with you, I think just to give an example, another stuff like renewable energy, right? And then Schlumberger, it's an organization. We also make a single division for renewable energy. It just shows that we pay attention to that sectors as well. There's not much thing that I can say now about hydrogeological, but I think because you have the things, companies they will look at it. Again, it's going to be driven about how much profit that it could gain from one sectors, right? But once it's become very obvious, I think it will also touch that sectors as well, the AI and all the machine learning stuff. Yeah. That's my answer. But I'm sorry, I haven't worked much about the hydrogeological myself.
Okay, so much, Mr. Sashi and Mr. Lutfi, for the answers. And perhaps if anyone has questions, you can send it through the comments. Or if you want to communicate directly verbally with the speakers, you can write down on the comment section as well, and the committee will give you permission. So we will wait for another minute. Okay, so a minute has elapsed, and since there are no more questions, and with the last question being answered, we have now finally come to the edge of today's webinar. And before we end today's event, as a token of appreciation, we would like to give certificates for each of our speakers. Firstly, I would like to ask the operation team for assistance to share the certificate. Hmm.
You're a good moderator.
Okay, so the first one is for Mr. Lutfi Nugrahadin, and maybe I would like for assistance for the operator to capture and do a countdown.
Okay, 1, 2, 3. Done. You can continue.
Okay, so the second one is the certificate for Mr. Sashi, and I would like to ask for assistance again to the operator to capture the moment and do the countdown.
Okay, 1. Oh, wait. Let's wait for the spotlight first. Okay, 1, 2, 3. All right.
Okay, thank you, Melissa, for the assistance. And to end our photo session today, I would now like to invite the whole participants to turn on their cameras. And for the operation team, I would like to ask for assistance again in counting down to capture the moment. Again, I would like to invite all the participants to turn on their cameras. So we shall wait for 1 minute. And I would like to invite again to all the participants to turn on their cameras. Okay, so now maybe to the operator team, could you help to capture and do the countdown?
Okay, for the first page, 1, 2, 3. For the second page, 1, 2, 3. For the last page, 1, 2, 3. All right, we're done.
Okay, with that being done, we have now finally reached the end of today's event. I thank you for coming to GSC 2020 first ever webinar. We hope the program has brought enlightenment to you. We look forward to seeing you at our upcoming events. Participants are now allowed to leave the meeting room as the event has ended. Good evening and have a good day.
Thank you.
Thank you.
Thanks, everyone.
Thank you very much, Mr. Lutfi and Mr. Sashi.
Thank you.